topic with counting is permutations. So the definition is just an ordering of objects. So we have a few facts about it that are helpful in problems. So fact one is the number of permutations of n objects is n factorial. So how do we do this? So a permutation is ordering, so let's pretend we order them in an arbitrary, just a line or something, so on, right? So we think about, instead of the line itself, choosing each spot as our independent event from fundamental principle of counting. So for our first spot, we have n objects to choose from. We can do any of them. We have n. What's the next one? Well, we can do all the objects except the one we chose before. We only have n minus 1 left. Then we only have 2 left, so now it's n minus 2. And we go so on until we have only 3 objects, 2 objects, and only 1 object left. And this is defined as n factorial. And that's basically it. So now there's a more general statement than this. The number of ways to choose k objects from a collection of n objects and permute them is this notation, npk, and that is equal to n factorial over n minus k factorial. Now this also basically comes from this. Well, we have n objects, but instead of n spots, we only have k spots, for example. So we would have n objects for our first spot in the k spots. Then we have n minus 1. All the way for our k spot becomes n minus k plus 1. Listen careful, that's plus 1. So this is equal to, we could potentially just multiply by n minus k factorial over n minus k factorial. Now what does this do? Well, n times n minus 1 all the way to n minus k plus 1 times n minus k factorial, which is n minus k times n minus k minus 1 and all the way to 1. Well, this numerator becomes n factorial. And that becomes n minus k factorial. So that becomes our new formula, n factorial over n minus k factorial. So now let's do a simple problem. So our problem is, how many ways can we choose for objects from a collection of 7 and put them in a line where order matters? Well, this is just a direct application of our formula. So our formula states that this is 7 factorial over 7 minus 3 factorial. And that is 7 times 6 times 5, 7 minus 4 factorial. 7 times 6 times 5 times 4 times 3 times 2 times 1. This is 3 factorial over 3 times 2 times 1. This cancels out. This cancels out. We're left with 7 times 6 times 5 times 4. Do some mental math and you get 840.